What do you have any strong opinions about Internet of Things?
You know, it's funny. You just asked me if I have a strong opinion. I think the answer is yes. There are very few topics very few popular topics I wouldn't have a strong opinion on. So the Internet of Things I find very interesting, that all of a sudden we collectively pulled our head out of our ass and go, oh my God, look what's here. It's not new. It is over 20 years old, and it wasn't as pervasive then as it was today. It was much more expensive, making it much more difficult to deal with or to experiment with because of the pricing. But honestly, the Internet of Things, not a new concept, not true. It hit mainstream. It's now been commercialized, or it's just at the start, I should say, of commercialization. But I mean, look, sticking an IP address on a washing machine. You know, I came up with the idea 20 years ago. So at least you could get a friggin' pager that tells you, hey, your laundry's done. Don't forget to take it out of the wash and put it into the dryer.
Yeah, I don't know if you've seen any of the statistics around it recently, and I think it was, I forget who did it, but a statistics company did it, and it said like 14 billion devices today, but by 2020, which is 4 years away, they're looking at 50 billion devices connected. So yeah, these things have been around a long time, but I think why everybody collectively pulled their head out, as you put it, was because
I eloquently put it.
It's because all of a sudden overnight it's like boom, everything's gone. I mean, cows have it now. You know, it's they're
but cows have always had, you know, RFID tags in research and development animals and regular cows compared to sticking a Raspberry Pi on something. I mean, what are we really calling the Internet of Things? You look at your badge that you use to badge in or out of a building. Right. Not only does that have RFID in it, it's an actual circuit that gets electricity from an external device that only works momentarily. There's no reason I can't apply an IP address to it and stick a protocol or any type of protocol stack. You know, I could create a protocol stack that it could communicate to, and therefore become true IoT. So the question is what truly is IoT?
Well, that's a good question.
You know, versus what are all these other devices, and why isn't this just the natural progression of things? Why is this whole big oh my God, when in fact our mobile devices and mobile technologies are in fact the exact same concept? Conceptually, I'm actually paring down a cell phone, today's cell phone. I can remove 6 processors down to 2 instead of 8. I can go down to a single processor, or I can go down to a partial processor. If I removed all that out of a phone and went to a partial processor and removed two-thirds of the functionality, I have IoT. That is a device that is standalone, that has its own power source, or it can be powered, that provides some sort of functionality that is programmable. Okay. The Atari 2600 fits that, right? It's just a bigger footprint.
Right.
So whether I look at a Raspberry Pi, or if I look at a Netduino or an Arduino, or any of the other myriads of M-blocks and other devices that are out there, plus all the ones that the professional manufacturing and development companies have, the question then becomes not so much what do you think of the IoT, but how are you seeing the evolution can progress, right? Because now the same issues that we've always struggled with, security is huge for IoT. Do you know how many, the Quickset lock manufacturer?
Yeah.
That you type in a code to open up your own front door, and it uses, and then you can cell phone over. That's been hacked. It was hacked within the first year that came out. That literally meant your front door is vulnerable. Right. That's just plain stupid. So obviously you don't want to do that. But that is a risk. That is part of the innovation risk that we're taking in order to implement these new technologies. And I think this IoT, commercialization of IoT is at its very beginnings still. That 20-year period is still its inception. It's not even reaching maturity level 1, right? It's just now getting out there in a bigger way. But I honestly believe, first off, if I've just got to get my opinion out here. Just got to get it out there. I hate the word phablet. That is just sheer stupidity for me to hear. It causes me to cringe when I hear that. Let's just call them what they are. They are mobile devices. And the size of the mobile device, regardless of the size, the fact it's a mobile device, it's a mobile device.
Right.
There's not a tablet versus a phone. There's only one key piece of functionality difference between an actual phone and an actual tablet. And the difference is I chose to put a cell phone or I chose not to put a cell phone in my tablet. That's it. Outside of that, it has processors, memory, it has software, it has functionality, a battery pack, and a form factor. So when we look at IoT, IoT has processing power, it has energy source, whether that's battery or pulling it direct off a line. It has software, and it may have one or more pieces of hardware that's attached to it or for some sort of functionality. So at its core, where is the true difference? And the true difference is around the capabilities, how much processing power, how many simultaneous tasks, what that device is pinned to, only doing this 1 or 2 or 5 pieces of functionality. So, for example, my developer and I, Martin and I, took a Saturday together, and we ripped the sprinkler system off of my wall in my house, and we converted it to a net. The whole sprinkler system, wired up to all of the irrigation, is now 2 inches by 4 inches. That's the whole thing. And we did it with Visual Studio, and we used C#, and guess what? It works. Then on top of that, I created a web page that I could control it remotely, so I could sit out on my deck and press a button on my cell phone that I hit the web page from and turn on my sprinklers. Officially, that's IoT, right?
Right. Yeah.
Because now I made a cloud-based web application to control this device from. So there's the talk about the devices itself, and then there's the talk about IoT being part of the cloud and being part of the internet. Those are 2 separate things today. Eventually they may converge. But I don't know. Where do you want to go with that? What direction did you want to take?
Well, it's interesting because I think part of it is, too, I wanted to just tell you what Gartner's definition of it was. And they say a network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. And like you said, that's just about anything, everything from building automation systems, right? So building security, temperature control, lighting control. Like in my house, I have the thermostat and all that kind of stuff that's controlled from my phone, and I can control my, like you, but I bought a commercial one. I can control my sprinklers remotely from my phone. So we see all that kind of stuff. But then you're getting into other things. If you think about it, our cars now have embedded computers in them.
Oh, but our cars had embedded computers in them for
a while, right?
For over 15 years.
Yes. So this isn't anything new. I mean, building automation systems aren't new either. I mean,
No.
To me, that's not really new.
It's just the commercialization of all this and putting it into the hands of your everyday person instead of just big corporations. That's where the major change is.
Well, yeah. And if you look at SCADA-based systems, like automation control systems that may work in factories, refineries, and all that kind of stuff, that's been around for 20 years or more. So those technologies have been there. What has been different with them, I think that is different. And if you go back to that definition, the old way, it fits under that. I think what people are looking at them now, and they call them Internet of Things now, maybe because now they're connected to the internet, or they are connected to an IP address and now are using standard networks to do the communication, because SCADA used to be on its own closed systems.
Well, and most of this wireless automation still is, right? Whether that's whatever their protocols are. But the fact that it's adhering to a single protocol of its own propriety, or the internet-based set of protocols that are available, is that really the difference? Is that what we're trying to focus in on?
I don't think that is the difference, but I think that that's what people think the difference is, right? Because I think if you go back to Gartner's definition, it doesn't really make that distinction, does it? It doesn't say that, it has to be connected to the internet. That wasn't a part of the definition. And there's a question as to whether you want it to be able to be connected to the internet, right? If you want to be able to interact with it and control it, you're going to have some security around it. And the problem that you're going to have with security is you're going to have a device that has typically low-powered, low processing power, and then you're going to have to put some kind of security overlay on top of that. It's going to require, even if you do encryption, it's going to require additional compute processing power. I think that if you talk about where cybersecurity kind of fits into this, kind of where my wheelhouse is, you're opening up a whole myriad of bad problems. You talked about the door lock being hacked already. People have already hacked baby monitors. You know what I mean? You think about it, you have a baby monitor in your house, and that freaks people out. Oh, somebody's looking at my kid. Now, is there any harm done to the kid because somebody's looking at him? Not really. So is it the end of the world? No. But the idea that someone can hack into...
It's creepy, for sure.
Yes, it's definitely creepy. But if somebody hacks into the system and you're in the house and then they can watch you, that's where it's really... that's where it actually can become an issue of privacy and all that other stuff. So, again, but you have the baby monitor, doesn't have necessarily the compute power necessary to protect itself from all the risks that are out there. So how do you do all this stuff? I feel like we're going back 2 steps backwards because we went into and say, hey, we have to have security in depth, right? So it's not enough to have a firewall. We have to have firewalls on the host-based systems. We have to have antivirus and whitelist application. We got to do all this kind of stuff to kind of lock it down as much as we possibly can. It's not enough to be just behind a firewall. We get to the Internet of Things, we don't have the compute power to do all that, so what do? We put it behind a firewall, or we put it on a VLAN. We put it in some other type of way of trying to protect it, but then again, we're only going to be as good as the firewalls or whatever that we have protecting it.
Well, we may not even be that good, because if you allow, or if physical access is gained to one of these devices, and I have technical skill whatsoever, I'm going to be able to bypass it. Most likely. Like the Israelis, what was it? They fought and got around encryption on a device by heating a chip up with a hairdryer or a heat gun until it turned 1 bit. And with the information of causing that chip to turn 1 bit, they were able to decode the encryption software. It took them a ton of time, don't get me wrong, and it took like a long time, but they were able to do it because they gained physical access.
Right, and physical access is always going to be one of those issues. And when you have items that are just everywhere, if you think about it, when you talk back the Internet of Things, they're usually talking about things like hospital equipment, right? Monitors and stuff like that.
But those aren't Internet of Things. That's hospital equipment. That's monitors. Those are things that are not on the Internet. They're not cloud connected. And they shouldn't be necessarily cloud connected, and they shouldn't exist outside of their internal network only, right? So I kind of disagree. Internet of Things are my new Samsung refrigerator that you plug a network cable into.
Right.
And that's going to talk back to Samsung to tell them a status of the refrigerator and when the filters need to be cleaned. And then Samsung proper sends me an email to remind me to go clean out my fridge. That's more of an Internet of Things versus a highly connected device. Mm-hmm.
Yeah, and see, and that's, I think, where, again, this is like when cloud came out, right? When everybody's talking about cloud, it's really important to kind of get down to the definitions of what we're kind of talking about. Because
it's kind of hard because the definitions themselves either pre-exist or have evolved, right? Because 10 years ago, there was no such thing as cloud infrastructure. 20 years ago, there was no such thing as the cloud. It's actually technically 7-8 years ago, there was no such thing as the cloud. It didn't physically exist. There was hosted systems and ISPs, but not cloud-based computing technology. There were no frameworks or bots or anything like what we have today.
Right. There were things like it, but not what we have today.
There was nothing like So yes, there are things like pieces of it today, true, but there was not an example of, I mean, I'm thinking just even, like I said, 8 years ago, high performance computing, HPC, Microsoft's HPC is an example of this. HPC is used every day of the cloud. And the cloud on the Microsoft side, as embarrassing as this is for me to find out, it's Linux, right? It's not Windows. And that was a big shock for me. But the whole kit and caboodle is that, you know, my definition of the cloud, and I get into some discussions with salespeople. You know, I've had 2 sales guys who grew up in the storage and the networking worlds, so they feel that they're experts in these areas, and that they came back and say, the cloud has always existed today, it's nothing more than a big marketing scam. And the fact is that's not true. There are elements of truth to it, but the cloud itself, as it stands today, as network, as a service, infrastructure as a service, elastic services, compute powers without being tied to an operating system, without my application having to talk to an OS, that I can talk to a set of services without having to deploy to any computer, did not exist. 10 years ago, if I were to deploy a highly available website, so let's take Walmart.com and pretend that it was highly available, and I deployed that, what I would do is I would talk to my ISP or my own hosting company or me and say, spin up 15 to 30 physical servers. Then what I would do is I would deploy network load balancing. I would put my F5 load balancers out in front of it, and I would have a bank of these load balancers. And then what I would physically do is I would deploy my code 30 times. That's once for every one of these installed operating systems. Every one of these machines would have a unique name. Every one of these machines would have a unique IP. Every one of these machines would have an instance of my code. Every one of them would have a configuration file specific to it. When I deploy a highly available website today, I do none of that. Nothing. I do not stand up a bank of F5 load balancers. I do not stand up 30 servers. I do not install 30 operating systems. I don't deploy my code 30 times. I deploy it once, and then I can explicitly say how much bandwidth, how many processors, and how much storage we can use up to so I don't go broke doing it. The infrastructure to support that, the physical infrastructure, the logical architecture today that supports that and makes that possible did not exist 10 and 15 years ago. It didn't. There was no such thing. And so if any one processor, unit, or device fails, or if my machines are taking on so much activity that I just simply need more processing power, the services like AWS, like Amazon, they're elastic. They will grow with the demand. Nothing like that existed. And so the cloud today versus the technology of years past are actually physically different. And with this new concepts of network as a service, where you're building virtual switches, you're building subnets, hybrid networks, you're extending your network to the cloud, basically to the internet, that is not the same as creating a VPN site-to-site solution between you and some other physical location. Now you're going to a non-entity. You're going to some place that's made up of hundreds of places, and that physically didn't exist 5, not even 8 and 10 years ago. Just completely different. But that again, this is the world according to Bryan.
Well, I see a lot of times what people will kind of point to is they'll say something like, Yahoo email would have been an example of a cloud-based service in the past before the name existed.
But it isn't. It was a service. But that's the same as Hotmail, right? That would be the same as Yahoo, Hotmail, and it was. What was that? It was a single application on a shitload of equipment that didn't make it cloud-based, that made it internet available, but that is no different than putting up a singular website that tens of millions of people can come to and log into. That doesn't make it a SaaS-based service, right? These fundamental capabilities of elasticity and infrastructure deployment. At Yahoo, they had hundreds and hundreds and hundreds of servers supporting it that had copies and copies and copies and copies of their software everywhere. They didn't have instruction sets being sent off to CPUs to get answers back. They didn't have service bus technology and queuing technologies to make this ubiquitous. What they had was physical infrastructure that they supported, and they put a single application out on the internet that made it available. That's no different than a website. It literally is a website. Literally.
So I agree with you, but when you look at the definition here, and this is where the definitions come in for, when they talk about it, the definition now, the scalability, they would have considered it there, because if you were a company and you wanted to add a new user, you would just go online and you'd add a new user, right? I mean, you would just...
Yeah, but that's the same as a website, right? So any website you can do that to.
Right, and that's a whole other thing. I mean, because if you get to that level, you can say that, and if you look at the definition that the Cloud Security Alliance and NIST uses, it basically says it's a utility-based model. So it's like you flip a switch, it turns it on, and then the end user, and it's all about the end user experience, not so much what the for their definition, it's whatever the end user, the consumer, is going to do. And if the consumer can just flip a switch and say, I want to add 10 more user accounts, and you just do it without having to deploy hardware, software, or anything, then that's what would fall under this idea of cloud. Which
I think that's fundamentally flawed. I would disagree with the National Institute of Technology from the federal government here, because fundamentally every software package can do that. Fundamentally on-premise, and if I just took an on-premise piece of software and put it on the internet, then that met that requirement, and that is not cloud.
Well, I don't think it's, well, so I'm oversimplifying it.
Sure.
But that we can have that conversation at a different day, I guess.
Yeah. So I mean,
we're off the Internet of Things.
You and I have grown up. Literally, our experience over the last 20 years is the birth. 25 years is the birth of the internet. It didn't exist 30, 40 years ago. It didn't. There was no such thing. There was the Department of Defense. There was the DARPA net. There was the college university networks, which these were all the same things, right? Mm-hmm. But when you and I were in high school, there was no internet. The closest thing we could do is, go to a university and get on that university's network, where we could use Gopher. Mosaic wasn't even created yet. The protocol for HTTP wasn't created yet. And for an NDA, I can't put a definition in place based on an end user's experience ever. It just doesn't work. That's like saying my end user experience is that vaccines are new because the device that deployed it into my arm is now different. Right, I can take a pill, and now I have a new definition of what a vaccine is. The delivery mechanism, aka the usage, it's not a fundamental or foundational component in the definition of what is cloud, because cloud is a very technical thing. It has a set of features and a set of infrastructure and architecture that exists today that didn't exist 20 years ago. I mean, what is it? 20 years ago was what year? Or if you look now, I got to say 30 years ago, like 1984, 1985, when the IBM PC, or 1979 to 1980 is when the first IBM PC was launched, and that's the first version of Microsoft DOS that quickly followed suit within that same year. There was no internet at all. Right, modems had existed for years before that. The modulation and demodulation of digital information over a phone system had existed for interconnecting bank data with punch cards. Right, I mean, it was all in that same time frame within that plus or minus 5 to 10 years, and then the actual cloud didn't get officially launched until what year? Do you know?
I don't know what year. No.
So that's the problem, is when you look this up, you can't get you can get to generally agreed upon year, but you can't get a definitive year, right? And so that's part of the problem, because the marketing term cloud technology was generated or first coined not more than 8 years ago. And that's a lot of the struggle here, right? Because unfortunately we're in 2016. I keep thinking it's 2012.
I know.
But I base everything off of a marching time, because I was contacted by Microsoft for Azure on the Azure beta team just around the time that I was starting to go to my own, which was in 2007, 2008. So that means they've been in development 4 years before that. 2 to 4 years. I can't say for all clarity. So that means that from a Microsoft world, Azure really didn't exist pre-2004, right? And now Salesforce.com, who claims you never have to install software, it's software as a service, that's been around since 2000, 1998, 1997. But was it truly cloud technology, or was it just a super web application? And I would argue it was just a super web application.
Yeah, so let me give you the definition of NIST just so you can pick on it some more. So this is what it is. Cloud computing is a model for ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, i.e. network servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction.
Yeah, and I'd go on record to say that's a very poor definition. Very, very poor definition, because I'm going to ask them to compare and contrast that to defining what internet services were prior to the cloud, and contrast it for me, because quite honestly, the internet service providers of the cloud could do the same. There was nothing stopping me from taking an EMC SAN system, sticking it on the internet, and creating just simply enabling all IP addresses access to it. Right, so, and store it.
So you're saying that with their definition, cloud isn't anything really new, if we use their definition.
There is very little difference. There's very little definitive or defining difference between cloud and internet at that point, and they're describing everything since 1994, because in 1994 was the first time that we actually got the internet. Right, that was the creation of it. We have a definitive day when in 1994, how many websites were there? And it was like less than, 100,000 worldwide, or less, much, much, much less than that worldwide, because there was no World Wide Web. There was only HTTP. There was no www at the time, back in 1994, officially. I don't even think ICANN came out. I think they were still being formed. Because I remember being on the team, my wife was on Netscape and I was on Microsoft Windows 95. And when we were releasing Windows 95 with Microsoft, their first browser was Mosaic. It wasn't IE. And that it didn't release with Mosaic, but that was in the pre-release in those versions. And it was only the year before that, like 93, is when Netscape was really coming out, right? This Netscape had been working feverishly in the background for a year or two before that, but nothing was public. It wasn't commercial. But back then, the internet was a little more simplified. But at the end of the day, it still had the ability. You could create an email account back in 1994, or in 1998 with Hotmail, right? And you could sign up with hundreds of email accounts in seconds. Well, according to the definition you just read, that's a ubiquitous process for people that end users can quickly sign up and get provision to get a service.
Right.
That's now cloud? No, it's a super web application.
Super web application. Now we need to get a definition for super web application.
It's a scalable web app. I'm making the argument that their concept of scale. There is no difference between a highly scalable web application, based on their definition, no difference between a highly scalable and available web application to that of the cloud, and that is fundamentally wrong. That is fundamentally flawed. It just doesn't hold true. I think Don Hester can come up with a better definition than NIST.
Oh, thank you. I
do
appreciate that.
And I will back you. I'll co-sign it.
Well, I like your. I want to coin your term. Well, I'll let you coin it, but then I want to use it. Super web applications.
Yeah, that's just stupid saying my part. But yeah.
No, I like it. I think it's trending.
It would fit with the Gen X, Gen Y for sure. I don't know, but nonetheless, it's and this is where I think a lot of people honestly struggle because they don't understand, and because of the complexity of the cloud, because of the technical levels of infrastructure and architecture of the cloud, and no two clouds are the same. People can't wrap a definition around it because they can't understand what the fundamental differences are. And, like if I wanted to spin up, like in the old days, if I wanted to spin up 4 more servers that I can have failover or load balancing, I physically had to install an OS. I physically had to deploy my code. I physically had to set up second, third, and fourth network routing capabilities, so no two switches or routers were talking to the same 2 boxes at the same time, right? So in case did I have a network router failure? Did I have a network card failure? Did I have an operating system failure? Did I have a CPU failure? Did I get a blue screen of death? Did I get a DDoS attack? Right? All of these things are being considered in highly scalable applications. That's just nothing more than a friggin' web farm. That's what that is. It's a web farm for the web. It's a network farm for the network. It's a set of firewall and protocols wrapped around the security side of things, and so that when one device fails, it doesn't take down the whole kit and caboodle. Because back in the old days, it did. It did. If your load balancer went down, the entire farm went down. If you had crappy software and 2 of your web servers went down, your farm went down, right? So the scale and how you built that car together is very different than what you do today. Yeah. So I suppose if you can compare like a Model T to a Mercedes 300, all right, and clearly say that there's a massive difference because the user experience is different. Okay, but the mode of transportation is 4 wheels. It has an engine, and there's a gas. It takes a fuel. Fundamentally, those are the same. Are we no longer calling the Mercedes a car because of its user experience is better than a Ford Model T? There's the question. Is it fundamentally no longer an automobile because of the user experience and the new technology that's in that car?
Well, I mean, if you ask the Germans, it's beyond being a car.
it's the ultimate driving machine.
Exactly.
Right? But that's marketing, not a scientific response. That is buzz and spin, and that is the definition that's coming out of NIST: is buzz and spin, not factual, scientific, truly testable, provable response. But that's just me pontificating.
Your strong opinions again.
Well, my strong opinions. I would argue if you and I got off our butts and got and I'm all for this, by the way. I'll do it with you. Let's get an invite. Get ourselves invited to Microsoft's. Go to one of the Microsoft data centers where the cloud actually lives for Microsoft, and let's speak to Let's go up to Redmond. You and I can go up to Seattle. And let's go speak to a couple of the cloud architects that actually design the computing power that makes Microsoft's cloud together, and have them compare and contrast it to 1994, and compare and contrast it to 2004's web deployments in production at that point in time, and then again compare it 10 years later to 2014. I'm going to guarantee you that there's a clear, definitive change. There will be a ton of overlap for sure, but it's not marketing. It's not marketing.
Well, that's good to know.
That's like, okay, I've had enough of Bryan. I know the tells. Come on, man.
No.
But hey, if you really want to do it, I'll do it. We can go up to Microsoft.
Sure. But I think that you've made a good case, though. I mean, that there's something lacking in their definition. It's too broad, and it doesn't take into account some of the finer...
well, I don't even say finer. I think I say core differentiators. Elasticity is a core differentiator on scale. That's a core. A software as a service without being defined or deployed on a single operating system. When you deploy a website to Microsoft Azure, you don't do it to an OS. You do it to Azure. That's fundamentally different. And now I'm using Azure. I can do the same, or I can do similar with AWS. But AWS is nothing more than a massive amount of virtual machines in the world sitting on top of abstraction layers, which, again, 20 years ago didn't exist.
Like I said, I think your definition is, or your ideas and points and considerations are making sense. They make sense.
It's nothing more. They're at least interesting, if nothing else.
That's a good way to put it. Interesting. It's worth. This is the way I think. I think that it's important that you have these types of conversations.
Well, for the purpose of what, though? Because you career guys, the kids, the college students that are going today, do they need to know the subtleties of how these things are put together? I mean, that's an academic activity. They need to know how to become successful in the business and the operational world of IT, right?
True. Yeah. I don't for their aspects, I think, to better understand exactly what it is cloud. I think part of it too is to make sure that you don't get buffaloed by because even if you're an IT, no matter what you're doing, you don't want to be buffaloed by some sales pitch or some slick guy talking, oh, this is cloud. And that's one of the things that really got me is when the cloud came out, all of a sudden every vendor says, well, we have a cloud solution for that. And I'm like, okay, what is it? Okay, it's no different than what you had 2 months ago, but now you just slapped the word cloud on it.
That's marketing spin.
Yeah, it's all hype. And so I want to make sure that, I think for anybody, is that you don't get bought into the hype, because this is the funniest thing about this. So we've gone from Internet of Things to cloud, but these are the big topics everybody's talking about, right? So my boss came to me one day and told me, he said, well, this cloud thing, we should probably look into going it that way. And of course, he's not an IT person, right? And the first thing I'm thinking is like, where did this guy come up with this? I mean, why is he even saying cloud, right? Well, he read it in the Wall Street Journal. And so he read it.
There it got. What do you call it when it gets deployed? When it shows up in a newspaper of authority, right? Now it's got some weight to it.
Yes. And I think that is I think that's one of the things that you run into in your career whenever you're dealing with this kind of stuff, is someone's going to throw some marketing hype at you, and you're going to have to deal with it and say, okay, do I really need to just go to the cloud just to go to the cloud? I mean, and here's the funny thing, the government's definition of cloud is so huge, but here's where the rubber meets the road and why this is important and why the marketing spin is the way it is. The federal government, the CIO of the government, said we're going to take 20% of our budget and we're going to push it to the cloud. So, we spend X amount of $1 billion on IT for the federal government, and we want to take 20% of that and put it into the cloud. This is where the definition becomes really important, right?
Well, and I'm going to guarantee you that when that statement came out, it did not say whose cloud, meaning that it will not be the same public cloud that you and I are on, but instead will be their own virtual private cloud. And so they'll purchase cloud technologies from Amazon or from Microsoft, and it will be solely ripped and stripped and specific for them. So, for example, the Department of Defense, the DoD uses the cloud. Are you telling me that DoD is going to use the same Amazon web cloud that you and I use? I'm going to tell you, not a freaking chance in hell. So yes, they're going to say cloud, but no, they don't mean cloud. They don't mean our cloud that we all have access to.
Oh, yeah, they have, if you look at the requirements, they have to be approved. It has to be an approved cloud service, and they do the audits on it and all that kind of stuff. There's a very short list of who the DoD uses, and then other agencies, like when they use Google Cloud, it's on separate servers. It's
exactly. So can it still be called cloud?
Well, that's what we're talking about, right? So right now, according to the marketing hype, yes, it can, and it's completely fine for the federal government, even though that other people may not consider this necessarily the cloud.
Well, I don't have an opinion, believe it or not. I don't have an opinion one way or the other. I just ask the question because then it becomes private services, and so if that's the case, then I can argue that if they make the argument that it is cloud, then cloud has a definitive set of technologies that can be purchased and therefore does not fit the definition that NIST came up with, because now it can be separated and purchased as a separate product or service, separate from everybody else, which, again, is not the same thing. These sets of features that they're buying didn't exist 10, 15, 20 years ago.
Right.
So it backs up my argument.
Well, there you go. That's a good thing to end on, I suppose.
Yeah. Hey, you asked me for my opinion. With these folks telling us that it is or isn't the same as what it was, it's just marketing hype, because I don't think it is. We fundamentally changed the way that we do business. Now, software as a service is not cloud. And I think there's a clear delineation. Software as a service may exist in or on a cloud, but SaaS has been around since the creation of Yahoo Mail.
Right? Gotcha.
And that is a definitive difference between that and cloud. So, back in 1995, I was teaching second level. This was the first time that they ever had second level tech support reps for operating systems, but I was teaching second level reps of Windows 95 for the launch. And I had come up with a concept of saying, hey, I was teaching that cable modems were going to be introduced in the next 3 to 5 years. Nobody knew what a cable modem was because it didn't exist. It wasn't commercially viable or available, and it was still in development. But I brought it into the class to have a discussion about it. And I said, with the advent of cable modems, we're going to, until such a time that we can get fiber optics to your house, and everybody in the class laughed at me and said, first off, I don't know what fiber optics is, and secondly, there's no way that glass will ever come off a telephone pole to your house. I fundamentally disagreed. But I said, until such a time that it does, the internet is simply too slow. We need enough infrastructure to be built out. AOL hadn't owned the internet at the time because they were just an ISP. They were a hosting and a service provider, and they provided internet access as a gateway. But that was it. You got email. When such a time came, I said, I want to be the first to take SAP, which put more companies out of business implementing this software than put in business, in my opinion. And I wanted to put SAP on the internet and sell it as a leased software package to any company to come in and implement it. That was in 1995, I said that. And most people understood what an SAP was, but they couldn't picture or visualize this thing called the internet because they didn't know what it was. And then those who did know what it was couldn't get past the point that SAP was so huge and cost so much money that it couldn't possibly be implemented that everybody could share the same instance of SAP. All right?
Right.
And I couldn't get backing. I tried to go get funding for this, and I got laughed out of town. So if
you were ahead of the time. You were ahead of the time.
Yeah, but if you go to Google today, can you get SAP online? You certainly can. And you can be whatever size company as long as you can pay the monthly fee for it. And that software as a service. And I could have deployed that 20 years ago. The only thing that was preventing me was the fact that their software was a bear to configure and to do with multiple companies, but it could have been done. But was the performance of the internet, the reliability and performance of the internet wasn't there. It wasn't because cloud didn't exist. The moment that would have went live, that would have been called software as a service.